Well, first off, thank you so much for inviting me to come to this workshop. I've never been before. It was great to meet other people who had never been before, so we had a community powwow about, sort of our experience yesterday. What a wonderful, wonderful day and high quality talks. Really got me thinking, and in fact, last night, after seeing all of the talks, I disassembled my talk and put it back together. I was really inspired. And I was particularly touched by how many people in the audience are students, and so I decided to gear a big chunk of my talk towards forward-looking work. I should say I do feel a little bit like a foreigner in the sense that while I haven't been designing wireless mobile systems, I recently have moved into this product group that lives somewhere between research and business unit. They do prototyping of early technology, early standards, and so forth. And so I straddle this group that's called ostensibly Next Generation Standards, as well as one called the Internet of Things group. And so from the Internet of Things group, I bring the perspective of someone who's looking at use case-driven design. And from the Next Generation Standards group, I bring and cross-pollinate into the IoT group some methodology and sensibility around, well, how do you get your research out of the lab and into something? And that's really hard, and that is what motivated me to be somewhat of a mole in my business unit, in the sense that I'm there to try to acculturate them to be accepting of research that's forward-looking. And maybe that's another message here also, is that sort of bringing different perspectives into the community is a healthy thing. And so that's one of my messages with regards to how you design overall systems. Now, the topic of today is edge-ification of the internet. When I first told somebody about that, they were like, but I thought we were having the cloudification of the internet. So there's some dispute about what cloudification means, but to me it was always about outsourcing resources elsewhere, typically a warehouse-sized remote data center, and that the edge-ification is sort of the pendulum swinging back and the creation of cloud-like capabilities a little closer. Without further ado. So what do I mean really by edge-ification? How did it come about? What are the implications to a community like this that's really looking at wireless and mobile? And I decided that I would take really two examples of how there's been some impact of the edge on first wireless edges and then mobile edges. The first half will be about something that's very concrete, driven by one of these use cases from the IoT, and the second will be much more top of mind. Where is the research going? From the perspective of an adjacency, which is really data stewardship, and along the way provide some of a collection of perspectives, if you will, an industry perspective, my sort of natural living place, which is up the stack in the networking protocol stack, some sense about collectively when you look at the internet and not just the edge, what sort of technical ecosystem you need to comprehend, as well as a little bit about business ecosystem as well. And then finally, something that I've been engaged in a long time, most of my career, is standards creation within the network. And finally, some call to actions and takeaways from this. So, in the beginning, I would say that how the network really began to shift or be disrupted is because the IoT arrived, and with it, many, many devices. Depending on which study you want to cite, gajillions of devices, and not just devices, but also sensors. And, but at first we thought that that was the real disruption, was how many things we're going to be connecting to the network. But in fact, the disruption is all the data they're creating. And furthermore, not just the data, but what do you do with the data? So if you look at it, we've got 150 billion devices, lots of forecasts around the percentages of the data that's coming from IoT things, and that 50% of the data, for example, will be created and processed outside the data center in short order. 71% of all IP traffic will be carried over Wi-Fi and mobile networks, again, in 2022. And that if you look at how much traffic was on wireless and mobile over the last 15 years, it's something like, 800, 8,000 times the amount of traffic than 15 years ago. And so obviously you need to kind of repurpose your network if that's the kind of influx of data you're getting. And as I said, AI is really at the forefront of what's being used with what the data is being used for. And then something obviously that businesses care a lot about is, well, what do you think my annual business-to-business IoT revenue is going to look like? Another way to look at this is some of the trends, because the nature of the data itself is also shifting. A comparison here in this first chart to the comparison between what's going on at the edge versus in the data centers. CAGR, if you're not familiar, is compound annual growth rate if you reinvested the revenue back into the business. And how much of that data is having some AI attached to it. And I'm using the term AI very loosely because when people talk about the computation or computation in the network that comes alongside of the shifts that are going on now, a lot of that compute could be analytics, could be AI, machine learning, deep learning, and so forth. But I'm going to use the term very broadly. Much more of the data is increasingly real-time, growing at 30% of the data is that at this point. And again, back to what slice of the network traffic is really increasingly wireless, and where is it coming from? Is it coming from fixed wireless devices or from mobile devices? And so those are pretty large numbers. Now, something I should also say is that when we say that the data is infused with AI, I sort of think of the data as biblical in some sense. Like if you've ever looked at the Old Testament, there's like, so-and-so had so-and-so, they begot so-and-so, and there's like this long lineage of things that were self-perpetuating. And that's the data. The data is getting computed on, which leads to more data, which gets computed on, which leads to more data. So it's this self-perpetuating cycle. And that's what I think is going on here. From the standpoint of what's getting carried on the network, increasingly media, video everywhere. If you look at what's going on with video analytics, the amount of revenue there, also high definition, live internet video traffic is growing by 15 times what it used to be, from comparing the, 2016 to 2022, and this trend towards immersive media for AR and VR. So that's the backdrop. And so there are many people in the audience who have been pioneers in the realization of this movement away from the cloud. And the way that I've characterized what that looks like is we have a distant cloud problem. The cloud is too far away in the sense of the time it takes to reach it. Now, we've talked about the volume of data, but there's also this delay sensitivity. There are issues around trust. If you look at a place like Intel, which has a high manufacturing component to the company, we would never let anybody look at our data, let alone carry it over some network that wasn't ours. So and if you think about healthcare as well, there are regulations, certainly in the United States, about where you can move your data. So there's trust sensitivity issues that also relegate data to being a specific place and not being moved off-site. And then the issue of either connectivity or disconnectivity being intermittent. You may not have access to a back-end cloud. And finally, more in the province of wireless is we really do have to worry about the energy usage. And finally, even though you may have connectivity from somewhere rather remote, like an airplane, a ship in the middle of the ocean, and so forth, the costs for communication may be prohibitive, and that may curtail your usage of back-end connectivity. So clearly, we need all of these things, either the use cases or the data themselves that have these properties are moving us towards more proximate clouds. So what does this migration towards edge computing look like? I would say that I've kind of broken it down into 4 phases, and I think that we are clearly at the end of phase 2. But there are 2 more. The first is, originally there was the conversation around that edge computing is happening and it merely means the action is not happening in the data center, the legacy data center. And the implications of that is that we're going to have an edge, something data center-like at the edge and something in the cloud, and that functionality that you'd normally find in the cloud, which I would say includes networking, storage, compute, control, data management. Those are the kinds of things you would associate with the cloud. And I use the terms cloud and data center interchangeably here. But that those things are migrating virtually closer to where the action's happening, where the data's getting created, processed, and then the decision making is happening, because in IoT, much of what happens also is the actuation of things as a consequence of the data, processing it, and that the edge is really a physical place. It's a foothold in where you can host hardware, firmware, software, and services, and that even from the get-go, there was this sense that it was going to be a billion-dollar industry, billions of dollars industry, and it was pretty distinct from the cloud because the requirements of those applications were quite different from all of those applications that were very happy using the cloud. This second phase, I would say, is the realization that, oh, there's this proliferation of edges, and that maybe even a continuum of edges, but it raises the question of, where's the edge? Which edge are you talking about? Who owns it? And that I've always thought of it as a reimagining of the data center in all of these different places, and these represent many of the conversations in the Internet of Things group around, well, I'm going to put a data center in the smart city, in my building, in a home, in a car, and so forth, even all the way to the extreme edge of the network in your devices themselves. And the car, sort of represents those kinds of data centers. But you could have a micro or femto data center that you share or make available to other things around you that is simply your device. And that it perpetuates the sense of dynamic sharing of resources that we have come to know and love in data centers. Where I think it's going, I think we're in the middle of phase 3, which is that if you were to compartmentalize this continuum, people have used these terms cloud, edge. Fog is where is something I would associate with the wireless and mobile edge, because again, it's sort of closer to the devices. And ambient is even smaller notions of data centers and so forth. But this aspiration, at least, to be part of a continuum, maybe hopefully a seamless continuum. And what does that raise as a question for developers who are going to build for an infrastructure like this? They don't care where the data is coming from or where they're going to host things. They're going to ask for a service, and something somewhere, an orchestrator or something else, is going to decide where in that continuum to place those services. And the other thing that finally has happened, which I've been very pleased about, is that the conversations around edge computing have encompassed more than just the computing. So it's a bit of a misnomer. It's not just computing. When you have computing, you also need storage and other things. So I think that that's a healthy change, and that the continuum includes now the cloud. And this is why there's this tussle about, is it called cloudification or edge-ification? And is one better than the other? And I think where we're headed is realizing that a whole data center is not going to reside at every kind of physical place that you could find or virtual place that you could find in this spectrum. Instead, pieces of resource sharing might exist. So storage is the perfect example. So you're going to have distributed and disaggregated data centers, and that maybe the way they organize isn't so much as a continuum, but as a multi-tiered cloud of clouds or edge of edges, and that we're going to have a lot more dynamics and mobile edges. And when I say that, I don't mean MEC, which is MEC, this telco notion of the mobile edge, but rather, what would it look like if an edge, this pod or cloud or federation of things, actually moved around together, as you're seeing with drones and cars, platoons, and things like that. So here we are. This is sort of one instantiation of the data center, of the reimagining of the data center as a series of edges. And this has somewhat of a feel of a 5G network, sort of a telco instantiation. But the key thing to note here is kind of we obviously go from wireless things to the, and they get their attachment point at what's come to be known as a far edge, but in IoT circles, sometimes it's called, the edge gateway. And then it goes across the network, being driven by all of these edge-like characteristics. But where it lands is a network edge, but in reality, it could be many different edges. It could be local or regional data centers before it even gets to the network core, and finally a back-end data center. And the big thing to point out here is just, again, if the data center was too far away, these are the sort of typical round trip times, well, not round trip times, but the distance in time to these other parts of the network. Something that's been happening at the same time that all of this edge-ification has been happening is that in the telco world, there's been this conversion of all the places where their points of presence are, where normally there'd be switching equipment. A lot of that equipment has been either retired or it's been consolidated, through workload consolidation and network function virtualization. And so suddenly at the same time, and maybe as a contributor to this, there's infrastructure out there that is going away and being replaced, and space opening up in physical places. And this is just an example of a major US carrier and the numbers of COs or central offices. And this is just what it might look like if you had about several thousand of them in the US. And the anecdotal input is that there are about 150,000 of these places where an edge might land. And these are just the typical already existing buildings. What of RSUs, which are roadside units? What of lampposts and signage and anywhere else where you might physically attach something to a building, cameras as a point where edge compute might happen. So the question is, what might this actually look like? And maybe the equivalent here would be to say, where are our warehouse-sized data centers? How many of those exist by comparison? And to get a sense from some of our cloud service providers and the scale of those. So I need a corollary map. But the other thing that I thought about coming into this community was to ask, well, hasn't the wireless edge and the mobile edge been around a long time? And so I went and I consulted Google. And I looked at the trends about the usage of these terms, and remarkably, could see over time, it only goes back to 2004, but I could see that there was some momentum behind edge computing, but I could also see that the wireless edge has been a term that's been used for a long time, as has the mobile edge, and that mobile edge computing is, emerging beneath all of these. And then, of course, I had to compare with cloud computing, which completely overshadows everything else that's going on. But there's an interesting phenomena that I noted, which was sort of the tail end of this, starting in about 2015, which is that they've kind of all converged. It looks a little bit like maybe edge is in our vernacular now, at least from the standpoint of what it means now. So the question would be, well, what's different? I don't think that the wireless edge or the mobile edge used to mean what it means now. It used to be a location for connectivity. And so now the question is, how do we change that definition to bring data center functionality to bear on the problem? And that this notion that there are flavors of edges and hopefully independent edges seems less foreign now. So that was my takeaway, although I'd love to discuss that. So some questions for you. Again, I'm taking the spirit of the workshop as published on the webpage, which was, how do we have this discussion about, well, what's the implication of all these shifts about the broader internet and connectivity? So my questions to you are, how many clouds or edges should or will or must populate this continuum or this multi-tiered continuum, if you believe in that? And who should own them and offer what kinds of services? Because we can clearly see that the cloud service providers recognize the need for networking, and the telco communications providers recognize the need to be cloud service providers, and even companies that offer services like cars that are collecting your data and giving you all kinds of goodness as a result of that, they have their own clouds, and should they be what kinds of services are they offering? So it's just the question of what kinds of service providers are out there, and even because of the sheer numbers of those locations that will offer a physical spot for you to put resources closer, there's also this whole industry of leasers, because we know that in these telco rollouts of coverage that it gets harder and harder the closer you get to the end systems and to the people. And so they don't have the funds for that. Who's going to jump in? So that's a whole nother subculture that's quite interesting. Who's going to pay for the rollout? We know that for 5G, the telcos are going to pay for that, but who's going to pay for the RSU rollout of those kinds of capabilities? And can your municipality actually even afford something like that? I think it also changes up what are the peering relationships between those things. Right now, again, in the diagram that I drew that was the continuum, there's this implication that all those things are part of something owned by some particular service provider. What of edges, especially mobile edges, if they're moving around, who should they peer with? Should they have just a single provider? Again, if the edges aren't moving around together, what of mobile things should they be able to attach to the edge of their choice? And so those are just some questions to ponder as this architectural shift happens. So now I want to get into something that's, I want to return back to the features about the data and the use cases that are pushing us towards edge-ification. And the one that is near and dear to me is about time sensitivity and latency in the network. And because I am affiliated with this Internet of Things group and spend a good chunk of my time talking about industrial IoT, where that's top of mind. Now, if you were to talk to people in the industrial IoT arena, they would say we are in the middle of a really important industrial revolution. It's just as important as when steam and machines and transportation came into being, and then a second wave when electricity came into existence in the late 1800s, and computer and IT automation was our third. We are in the fourth industrial phase, and again, there's just a lot of airtime about, this is a very exciting time for industrial IoT, and it's not just that things are being connected to the network, it's not just that they bring intelligence, but once we have intelligence that we could, is there a hope of automating what's happening in our factories and so forth, and in general for industrial systems. Now, coming back to reality, this is a picture of a typical, what you might find in a factory. This is an Audi factory in Hungary. But I put this picture here as representative of when you ask what is going on in terms of networking in industrial systems, there is a huge dialogue about Ethernets and proprietary Ethernet technology, and can we even converge on a single kind of Ethernet that can provide time sensitivity? So that's a far cry from wireless and mobile edges. And so that's kind of the reality of what's going on now. There are some wonderful standards bodies that have been tackling this problem, and there are solutions coming to sort of more standardization in the industrial realm. But the end goal is to have, whether it's base stations or whether it's Wi-Fi access points, have some kind of access point in industrial in order to change up how you might design the factory floor. Now, I'm going to focus today on some industrial automation, but time sensitivity cuts across many different areas, whether it's vision systems or power and energy, automotive, aerospace, and transportation. And what we're working on specifically is really time-critical systems. And what I have here is, just a rendition of the complexities of various things happening in a typical network for industrial. And this comes from a fabulous paper that is the survey on what's happening with wireless in industrial, which I will cite in my next version of the slides, which I'll post. The key issue is that if you're going to be doing anything regarding time sensitivity, you need a good clock. And so how do you establish time synchronization, and to what kind of precision does it need to operate? And for these kinds of systems between nodes and hosts, we're looking at tens of microseconds to single-digit nanoseconds, plus or minus a microsecond. So these are very, need the precision, and fortunately that kind of requirement covers most of the high-volume applications that you're going to find in this realm. Now, timeliness is, can I bound the latency or the delay across the network and the variance in the delay, which is called jitter? And can I do so under high reliability, meaning I'm not going to drop very many packets, and furthermore, I'm not going to drop consecutive packets? And can I coexist? Can this time-sensitive data, mission-critical data, coexist on the network with best effort traffic, which is what runs over the general internet? Now, TSN is, or time-sensitive networks, is actually a term in the standards world, and it represents as is typical, a family or a bundle of microalgorithms that contribute to the umbrella standard. But as I said, the key point is that we want to have a standard around precision time, and I will say that all of these are, different collections of things having to do with low latency, reliability, and resourcing and configuration, and that the standards that have a P in front of them are ones that are in flight for those of you who might want to get involved. But this is sort of where I wanted to land in this discussion, which is, how does this fit into the broader picture on, how would you design from bottom, it turns out, bottom to top, a time-sensitive network? And so the crux of it is this TSN 802.1 is its name. And the end goal is to not only support TSN-enabled Ethernet, which is the only thing that actually exists right now, but to support a whole family of different wireless technologies, the most mature of which is Wi-Fi. And there have been demonstrations of Wi-Fi. Sadly, there was going to be a really exciting one at Mobile World Congress that got canceled recently because of the virus, having to do with robotics and human interaction, but also emerging work in the 5G realm under the URLLC canopy. Now, for those of you, I know that yesterday when I was at the poster session, there were a number of students who are working in areas relating to the physical layer, the layer 2, and so that was very exciting to me to see. I naturally live one layer above that. I live at let's go back. I live at this layer, which is considered layer 3, which is the IP layer, which is really, to characterize it, it's the layer in the internet protocol stack that people call the thin waist, but it's really, you can think of it as the envelopes into which you put your packets, and miraculously the post office or the plumbing of the internet gets those packets to where they're going. And so that's fine and good if you're going to design layer 2 protocols. Actually, what I wanted to point out that this ... means is, take your wireless protocol of choice. There is an opportunity to bring time sensitivity to many other protocols, and there's a wonderful community to support you in that. So if that's something interesting to you, there's a need for that, for operating in these industrial settings. There's a new working group, there's an old working group called Deterministic Networks in the IETF, which is a standards body I've been affiliated with for many years. They're the ones who brought you IP, TCP, DNS, all those beloved acronyms from acronym soup. But the layer 3 is a partner to layer 2 because it augments this ambition to support time sensitivity in subnets, and so it gives you this ability to, in industrial settings that might have 2 Ethernet subnets that need to be connected by a wireless connection, it would allow you to cross subnets, do that, or vice versa, where you've got two wireless networks in an industrial factory and you want to use Ethernet between them. And so those are the kinds of use cases or scenarios that we're trying to support here. But the point is to be able to have heterogeneous subnets in your factory there, and to be able to scale up. And so that's the point of this deterministic network working group. Now, the new thing is that there is very little wireless in factories for a whole variety of reasons, not least of which are interference. And, but the end goal is that we're going to have we want to support lots of mobile devices, we want to have ease of configuration, and we want the installation to not cost very much. So where is this going? There's been a group that's been spun out that's going to look at bringing determinism, somewhat of an oxymoron, deterministic wireless networks. Because, of course, you can't only approximate determinism in wireless networks, but to try to foster a community or family of these layer 2 protocols that all behave similarly, and to help use a series of techniques to compensate for the fact that your networks are going to encounter interference, obstruction, noise, and so forth. And the key idea here is to take your wireless networks and to really provide a centralized scheduler for these wireless segments to guarantee the delivery time and also to save energy. And so there's some trade-offs there about latency and availability versus bandwidth and energy. But suffice to say, there are a series of mitigation techniques that you can use across a variety of domains. And so diversity is good in this domain as well. And what I've shown here is this notion from Wi-Fi specifically, where in its uplinks, it uses multiple access points, and in its downlink communication, it uses multiple access points to try to reach the sensors or devices on the factory floor. And so those are the kinds of techniques that are happening here. So I want to speed up a little bit. So this work is going on in the IETF. But I also wanted to show you the roadmap for the requirements here, because the latencies are quite different depending on the class of work that's going on. And this is a roadmap in time as well. So again, you can see the shrinkage of the latency, the increase in the reliability, the sorts of applications, and then the different flavors of, from Wi-Fi 5, 6, and so forth. It's likely to be Wi-Fi 7. And then coming up behind it is what's going on with 5G. Again, if you have an interest in time sensitivity, there's certainly an opening there for contributions on that front. This is the collection of family of protocols and groups that are working in this arena. There's even a certification group called Avenue, whose use cases are not only industrial, but also automotive and professional audio and video. I'm going to just say one more thing about this use case and then flip the switch, because I'd like to talk to you about also wireless edge. But the point here is that it's not enough to, again, when you have a time-sensitive network or you have an application that requires a time-sensitive network and it arrives at the network with a quality of service, how does that get comprehended not only across, throughout the stack, as I showed you, but also end-to-end? And so there are some capabilities coming in 5G which are around slicing the network, which is basically reserving parts of the network in order to continue to support quality of service across the network, the broader network, not the industrial network. And so that's all I'll say there, but that's a wonderful area for how wireless is emerging. Quickly, that this is also leading to more localized or private networks in industrial settings as well as venues. And that's a kind of a new transition as well. So I'm going to skip all about 5G. I suspect you all know about it. What I would like to do is spend some time talking about and speculating really about how is the mobile edge getting influenced by this transition, this edge-ification. And I want to return back to the abundance of data. Now, I'm going to go through a series of open issues that I think are they're adjacencies, but you'll see in the end that they all come back full circle to impacting the mobile edge. So again, there's a other community inside the standards body of the IETF called the Internet Research Task Force, and this is a place where, one, you don't need membership, you can participate remotely for $0. It's academics as well as industrial people coming together to design networks. And this is one group called Computing in the Network, and this is obviously something that comes out of the edge. What does it mean to support in-network compute? Are there unifying ways we should look at in-network compute? You know, we talk about containers, we talk about Kubernetes, we talk about Dockers, we talk about P4 and programmable switches, Tofino switches, and what does it look like when you have to program the network? And finally, there's another class of compute in the network, which is FPGAs and ASICs and other kinds of accelerators. So do all of those come under the umbrella? How do we actually find the data that those things need? How do we marshal it? How do we decide where we're going to place it? And how do we expose its availability and yet preserve its privacy? The other thing that's happening, because there's so much volume of data, is maybe we can't really move the data at all. The data, the traditional understanding of data. The traditional understanding of data is that it's sensor information, it's measurements and so forth, but the data is any collection of bits. And so now we're moving the functions to the data itself. And so we're moving the services, we're moving the AI and so forth because we simply can't move the data. So what's the impact of all of that? There's also some very interesting work that we're funding on trying to take professors Andrea Goldsmith from Stanford and Ed Minier from Northeastern, and putting together two individuals, one a caching expert who's got wireless knowledge, and the other a wireless, lower layer wireless expert, information theorist, putting them together to identify the metrics that you need to really do the optimizations around where the placement of these services go. Because too often, when people remain in their comfort zone, they don't, when they design systems, they stop at the edge of the wired network. And so how do we begin to acculturate these two different groups of people? So that's also a recurring theme here, is that boundary between the wired and the wireless is an interesting place for cross-pollination and to get people together who wouldn't normally work together. So there's work going on that Intel's funding in that regard. There's more specifically, is there now edge data, this perpetual motion machine of data and AI and processing and metadata? The data is getting increasingly scattered around the network. And do we need actually new or existing protocols to be developed in order to find it? Or do we already have something that could be modified? Is there a DNS for data? And furthermore, should we separate out a DNS for IoT from a DNS for data? Aren't they just the same thing? Isn't data just a type of thing that you would find in the IoT? Or should we have a, we were talking yesterday, some of us, about space, the final frontier, and there's the interplanetary file system, which is also about trying to create file systems across vast distances. There's also very interesting work with regards to the information-centric networking community, because some of the principles there are very, very interesting now. The key idea is that as data flows through the network, one, you're naming it or you're exposing the attributes about it, which may or may not be a good thing, but it would allow you to query for it later, and you're routing based on the attributes about the data. And furthermore, that you're caching data natively in the network. Something like 75% of all data is stored in the CDNs, the overlays of content distribution networks in the internet. So how would that change up that kind of infrastructure if, as the data was flowing through the network, we opportunistically cached it at a lower layer in the network? And then finally, we were also talking, Shuja and I and others, about how do you represent and describe things and their attributes, whether it's quality of service, whether it's policy, and other characteristics that you need that would help you in the quality of service time sensitivity discussion. So this is another problem that we need to solve. I will say that And I've already told you that this seamless interoperation across static and mobile edges is something that we know how to do handoff in the internet, and that sort of works between layers 2 and layers 3. So as things move around, you don't break your applications that are running above. But there is a revisitation of how that kind of handoff is being done, and is there a better way to separate out identifiers from locators? And so that's very interesting work, which I think could come to bear here. As we talked about earlier, there's a tremendous amount of data going on in the visual space. And so how do you process and store all this data, especially if it's flowing in the reverse direction? So something we're not hearing enough about, I don't think, is what is the life cycle of that data as it goes up the network. It flows upstream, for which the network was not necessarily provisioned, and especially what's happening at those collection points where it converges, and maybe that's where some processing is required in order to decide, do I really need to send all this data? Which should I throw away, and so forth. One of the interesting use cases is something that we call ubiquitous witness, which is when you have dense IoT deployments, what happens is that when an anomaly occurs, when an interesting event or a rare event occurs, you now have a whole collection of things that have all felt that event or have all sensed that event, and do they all need to tell you about it? Now, that's one way to frame it, like in an industrial setting. But what about in the city, where it's nice that I have a whole bunch of cameras that might have seen that accident in the intersection. And maybe those cameras are, some of them are owned by the people in the cars, and some are owned by the municipality because they're hosted on lights and traffic lights and on the roadside units and so forth. And how do I get all of that data? How do I find it? And once I find it, once I decide which is the best stream or streams, could I stitch that information together to form a 360-degree point cloud, so I could actually walk around my data? And although I've used the example of video for that, you could imagine any kind of these dense IoT deployments where wouldn't it be great to walk around your data? And so this idea of stitching as information flows and cascades across the network is an important one. That use case also helps me introduce this idea of, okay, now I've got all this data, it's around the network, how do I query the network as if it were a database? Can we support that kind of functionality? And then you might ask, well, how does all of this, what does this have to do with the mobile wireless edge? Here's some thoughts, having given you that backdrop, okay? I would claim that these mobile things are leaving a trail of data, kind of breadcrumbs, along their paths, and at some point, particularly cars and so forth, drones, other things, you might want to be reunited with your data or know where you've dropped it after the fact. There's going to be a need or an ability to decide which edge to connect to. Is there some kind of trust calculus that we can create that will help us decide which things are better or worse, either to connect to or to allow connections to us? And even this notion that will the data that's coming off of all of these things create some sort of typical migratory patterns, think flocks of birds, and some of that could be enabled by the AI that we're doing. So we're looking historically at how the patterns of where the data can and should flow and who's interested in it and so forth as it flows upstream. And my favorite, as someone who doesn't come from the mobile world, at least originally, my favorite idea is, and you can tell me I'm crazy, is what if the infrastructure was willing to share its intelligence, its insights about how the natural health of the network itself? Could I deploy mobile edges with resources to these spots in the infrastructure? So if you haven't seen this movie, there's a movie called The Iron Giant where it's kind of a transformer and it comes apart, but all the parts know how to come back together. And so kind of having a base station that was made up of many parts that kind of came and went as the service needed to be redeployed. And along with that, just to be even a little crazier, is to have some sense of where I'm being deployed to and could I aesthetically blend in to the environment or not be near the houses that people are annoyed with the radiation and so forth. So there are all kinds of things that you could be using the data for to figure out where to place things. So let me try to wrap up here, which is my question for you about questioning the status quo. I think that the Edge-ification begs the question, is there a data economy? And how are we going to liberate this data from the fiefdoms where it resides now? So, but we want to reward those who are providing services for data, but how do we enable something that's more about co-opetition than competition? And then I finally want to say that there's the call to action that I am thinking about is in just the last few months, there's been these amazing pronouncements in the newspaper around climate pledges for zero carbon emissions, for negative carbon emissions, and the telco industry being a part of that, actually. But the question here is, now that we're moving from traditional telco services or cloud services and so forth in the back end, how do we ensure that as we deploy all of this capability throughout our cyber-physical system, our spaces around us, that what we're deploying has these kinds of properties that are actually sustainable and take the good practices from the data center. So let me say one final thing, which is I want to talk to you a little bit more about standards. I know you probably have this notion that standards are kind of a boring place. People produce these 400-page specifications. But what I have here is your PhD on the left, and I have here on the right, although it's very hard to, let's see if oh, look at that. This is the specification for TCP that we know and love. And so what I'm trying to point out here is that there is actually, and notice I didn't say versus, I wrote and, because there is this wonderful synergy between doing research and then getting it out into the world. And one of the venues for that, which has been a lifesaver for me, is in the standards world. And it has the same kind of arc as research for your PhD. It takes even longer. It's probably the place that takes even longer to publish your work than trying to get into a journal. But once it gets published, it can impact many, many products, billions of people. So that's my shtick about why standards would be a fun place to live. And then finally, I spoke to you about what this IETF is. It actually has a research component